I'm Tim Ventura from American Anti-Gravity, and we're joined today by Greg Henderson, the co-founder of RxPax, the company developing the Hendo Hoverboard. What his company has achieved is a true breakthrough in advanced propulsion, because not only have they created a stable, self-propelled levitation platform with no external power source, they've also begun to successfully market and commercialize this technology as well. So Greg, I want to thank you for joining us, and I really want to congratulate you on achieving a dream for levitation technology that thousands of people have pursued and fallen short of for decades now. Now, if it's okay, I'd like to start out by asking about what inspired you to start this project.
Well, Tim, first of all, thank you for having me, and I really appreciate what you're doing in exploring these very important questions. Well, I'll just get right into my answer. The inspiration for the hoverboard actually came from the desire to solve a problem that we've been working on for quite some time, and that is how to more effectively build structures in areas subject to earthquakes and floods and things like rising sea levels. The initial solution we came up with, which is a low-tech solution, we had a patent for that issued in July of this year for what essentially is a three-part foundation system. And in this foundation system, the buffer medium, which separates essentially decoupling the structure from the earth, it can be typically a liquid or a gas, but why not an electromagnetic field? If you can levitate a train, why not a house?
Ah, okay. Interesting. Well, so you'd started pursuing this then from kind of the geometric aspect and the structural foundation. I was going to say, were there a lot of dead ends in your research? But if you're approaching it from that perspective, if you're substituting a magnetic field, it seems like that might cut out a lot of those, potential dead ends, I guess.
Well, we did encounter a lot of dead ends. Yes, we discovered many, many ways how not to hover something. But in the end, what we arrived at was a much more efficient method of transmitting electromagnetic energy, and we call that magnetic field architecture.
Oh, okay. And you're kind of jumping ahead of my questions a little bit, but let me roll back into the company website here. It's online at rxpax.com, and visitors to that site might be surprised to see that you have a rather large development team already on this project. Now, I wanted to ask, in terms of the team and in terms of the project, and again, it's not so surprising, I guess, looking at the origins in the building industry, but were a lot of these colleagues there from the beginning, or are they more recent additions to the team as you begin to commercialize this?
Great question, Tim, and most of the folks are relatively new additions. The core team that we've been working with is essentially Jill, our co-founder, and coincidentally my wife, and Victor Espinosa, who was an architectural intern and who's been with me from the very beginning working on the other solutions. So that's been the core team. And as we've grown, we've reached out to folks who are the best in their areas, and it's just really excited about the folks we've managed to pull together. They are, to a person, just really good people.
Wonderful. Now, when I was writing the questions for this, I was thinking about, why the hoverboard, right? Because, I mean, the movie put it out there, and there's a certain perception that people have, and then it kind of clicked into place for me. He said, people get the hoverboard, so it's an excellent place to start in terms of introducing this technology to the public. And I'm wondering if that's why you picked this application as kind of that public launch, I guess.
Tim, you absolutely nailed it, and I'm really enjoying your questions there. Quite astute, but you got it exactly right. If we want to solve some really difficult problems, they're going to take a lot more resources than what we have currently. We need to start somewhere, and why not start with something that everyone gets? The hoverboard. It just sort of picked us.
Yeah. Well, has it been difficult to stay on track when there are so many commercial and industrial and scientific applications for this technology out there, has it been kind of difficult to rein it back in and say, you know what, we're starting with the hoverboard, that's where we start, and we can tackle these other things once we have a commercial success?
It has been very difficult. As you can imagine, our advisors, particularly on the business side of things, are continually asking us to focus, and so focusing is what we're doing, but in a very broad way. We have defined the major market verticals that we want to tackle, and hoverboards are just a good conveyance to all those verticals. And they are transportation, of course, industry and industrial automation, the structural aspects, and the entertainment, of course.
Yeah. Now, I hadn't considered entertainment, but I guess that would fit really well. Now, in terms of finding support for this project, has it been self-financed pretty much until recently? And then I guess I should also ask, has it been difficult to find support both on a personal and a business level? Because, with technologies like this, there's always the giggle factor.
It's Jill and I have put our life savings into this, and we reached a point this summer where if we were going to move forward, we needed to get some additional outside help. And so we tapped our friends and family, and through our very generous group of close friends and family, we raised $1.5 million that have funded us and will fund us for the near future.
Oh, wonderful.
But the Kickstarter, of course, is just, it's really important that we pause to say thank you to all of our backers and supporters, and because it's with their help and their encouragement and ideas that we're able to move forward. And also that, well, I don't want to cut off any of your questions, but that gets to a very important point of why we chose to do a Kickstarter. I don't know if you'd want me to get into that now or not, Tim.
Oh, yeah, no, feel free.
One of the reasons we chose such a public and the crowdfunding, the crowdsourcing platform, Kickstarter, is to get the technology into the hands of all those tinkerers and thinkers, all those folks who can get one of our white box developer kits in their hands, open it up, take the hover engine out, and use it in ways we can't even imagine. The underlying technology is we want to make it available to everybody. We're trying to inspire co-creation on a global scale, and by seeding this hover ecosystem, by getting the technology out there, we hope to be able to tackle problems that, again, we're not even aware of.
Yeah, no, that makes complete sense. And to be honest, I will probably be in the market on your Kickstarter project here as well in the short term. But for anybody in the audience who also wants to contribute, the place to visit for that would be if they go to hendohover.com. That's HendoHover, hendohover.com, right? That's the best place to get started.
Yes, Tim, and let me point out too that that's the white box developer kit. There's another version which is the white box plus, and the plus stands for propulsion and control, because as you mentioned, this technology has its own inherent method of propulsion and control, and that makes it quite unique in the family of magnetic levitation techniques.
Yeah. And so, when people go to Hendo Hover, if they contribute to this project, then, and now, as I understand things, the kits, and the reason I ask is we have a lot of people in the maker audience, and so they would be wondering about this. Those kits don't arrive, though, probably until next summer, right?
That is correct, Tim. Yes.
Okay. Well, yeah, so with this technology, you were talking about the propulsive aspect of it, and that was one of the things that I looked at was, I'm familiar with inductive levitation, which is kind of what I gathered this as, but it sounds like, just from looking at it, the secret sauce for this is the magnetic field architecture that you described, right? Is this something that you could describe in a little more detail to me?
Well, I think that, particularly with the sophisticated audience that you have, I can sort of just touch on it in general terms, and I think you'll find it sort of similar to what you know. If you take, and what our hover engines do is they focus a very intense magnetic field, and through a method of induction, we create a corresponding equal magnetic field in the conductive surface below. And then, of course, just like two like poles of two different magnets, they repel one another. And that's the essence of what we're doing.
Oh, okay.
We just happen to be able to do it in a very, very efficient way.
Okay. So are you now? Is it repelling off a hysteresis effect? This might be getting in too deep. That's something that I'd heard of in the past. Was you're creating the field, but then you're switching it rapidly and relying on hysteresis for the actual repulsion.
There are actually a few ways to apply magnetic field architecture, and we're exploring all different techniques. And so, much like a lot of the other techniques that involve things like Hall sensors and electromagnets and or supercooling and all these other more advanced, much more expensive techniques, we can actually take advantage of all of those systems as well. So it would be really interesting to see people start to combine these different technologies in ways that we haven't yet.
Well, and I think, now that you're reaching out to the public with it, I think that is really, again, I think that it can't be understated, or, it can't be overstated enough. I'm sorry, what an achievement you guys have made. I mean, not just in terms of publicity, but in terms of moving forward commercially, in terms of having something that's available. People have come and explored it. There are lots of videos online. So there's a lot out there for us. It's not just a compartmentalized little project. And I think that's a major achievement.
Thank you, Tim. And I want to hand it to you and your audience, your readers and viewers and listeners, because it's these are the folks who think for themselves, who explore ideas, and tapping into that. It's just we are, one thing's for sure. We are going to discover some amazing things with this technology, and it's through folks like you. That's what's going to make it possible.
Yeah, absolutely. This is exciting. Now, in terms of the induction effect, in terms of the magnetic field architecture, is this the levitation has to happen over a conductive surface, and so there is a limitation to the technology there. And from what I gather, you're using copper at the moment, but can it use any metal, or does it require copper because of the higher conductivity?
Another great question. We need a conductive surface. Now, the type of conductive surface has everything to do with efficiency. The more efficient our engines become, and we are just beginning to optimize them, the more efficient they become, the less conductivity we'll require. So copper works very well. Aluminum also works. Different alloys of aluminum work much better than others. The 1100 series, which is something I never get into with a typical interview, but again, because of the sophistication of your audience, I'll say you want to avoid compounds that are electrically resistive. But there are a whole bunch of other exciting materials that we are starting to explore. Carbon offers all kinds of unique properties in its various forms that it comes in. But there are just some amazing composites, carbon compounds, particularly things like graphene, for instance. And our friends at NASA keep talking about things like conductive polymers, which are pretty, we can't wait to start exploring those as well.
Yeah. Now this really goes to the commercial aspects because for folks who have seen the video online, and let me again refer them over to hendohover.com. For folks who have seen the video, you guys have a half pipe built, and that's copper clad. And the hoverboard it works just fine on the copper clad half pipe. But when you start to look at these other substances, I think that highlights again the broad nature of materials that you'd want to consider for like a vehicle application or industrial applications where instead of a half pipe maybe you'd have to do this on a road or a factory floor and you just need lots and lots of material.
Yeah,
Sorry.
yes, and I didn't. When you've started my wheels turning, but please continue, Tim.
Oh well, I guess what it comes down to, and actually I think I'd put this down there a little bit further in the questions, but what I had thought was I was like, at some point there's got to be a formula, and this depends on engine efficiency, where it's a cost per square foot, right? And that's what it ultimately comes out to, where you can say, okay, we have a X amount of square footage, it's going to cost Y amount of dollars to cover it. And then the advantage is, because it's a passive surface, you could levitate over this thing indefinitely, presumably. So.
Yes, and since we began with our first prototype, the cost of the required surface, it's now a fraction of what it was because of the improvements in efficiency. When you consider this, and again, there are applications that necessitate large amounts of infrastructure, road systems, for instance. But maybe we start with just one lane, for instance. The HOV lane could have a new meaning here shortly. But there are plenty of other applications that don't require a lot of infrastructure, whether they're contained, small areas, closed loop systems in places like airports or factories, for instance. And then again, there are lots of applications that are essentially self-contained, where there is no additional requirement for infrastructure.
Yeah. See, and I think that those are great starting points for this, and so for folks who might be looking at it saying, well, okay, a half pipe is one thing, but how do you do the infrastructure of the United States? I think that the model to look at might be the Tesla electric vehicle, where it starts in a city, right? And then once they have their electric power stations there, then they're able to do part of the interstate, and then they're able to do interstate through several different states. And before you know it, they've got the infrastructure outlined, so.
Tim, there's one of our team members in particular always points out to me when we get into these conversations that the U.S. infrastructure, the road system, the freeway system, the trillions of dollars that have gone into the construction of that, essentially it's taxpayer money to finance the products from GM and Ford. So there's been a whole lot of money spent on infrastructure already. With a little bit of modification, we can actually move people and material much more efficiently.
Oh yeah, absolutely. I mean, this allows people to repurpose that infrastructure, and one of the things that I like about your design is the power supply is self-contained on the hover device, the vehicle, the board, whatever, which I think is a tribute to probably battery technology and a lot of the computer controls that go into it, right?
Well, we are really fortunate to live in a time when we all have access to this amazing thing called the internet. This flow of information, there's no better time to be alive, in my opinion. And we're also, our team, we are taking advantage of the latest battery chemistries. All the components, I mean, these are relatively new developments, and it's just amazing what I think we'll all be able to do. That wasn't the most eloquent answer, but
well, no, it makes sense, and I mean, one of the things I was thinking of when I thought of the onboard power, and it looks like you guys are using laptop cells. Well, and again, this goes back to the Tesla company. I believe they're building what they call a gigafactory in the Southwest somewhere. that should bring the cost way down on these units. So, yeah, I think that the time is right for it, and that's why we're seeing some of the pieces come together, and hopefully that'll be kind of the rising tide that lifts all ships, in terms of this technology.
Just for a little bit of comparison, so you have your audience has at least one metric. Our hoverboard runs on 64 cells. The Tesla Model S, by comparison, has 7,000 cells. So we're actually doing pretty well efficiency-wise.
Yeah. Well, now, once you turn it on, how long does a charge last? And I guess I should ask also, obviously weight is a big part of that, and there's kind of a corollary to this that I'll come back to in a sec. But what kind of runtime do you get off the 64 cells?
With the average rider, it's about 7 minutes. However, we haven't optimized for ride time, and the reason is on a hoverboard, for instance, it's kind of a workout. People are done after about 3 or 4 minutes. In other applications, we'd want to pump that up and achieve the appropriate balance with the payload and optimized operation time. So we haven't even really begun to explore that.
Yeah, and then I guess one of the other thing, and this goes back to the efficiency question. This is further down the road, but at some point you might be able to translate this into horsepower also, which would be interesting, because that might take it a step further towards hybrid vehicle engines or something where you can benefit from some of the existing efficiencies in power generation. But
well, we can actually do. I think the conversion factor. I think it's 746 watts per horsepower. And right now, we're operating in about the 10 kilowatt range, so 10,000 watt range on the hoverboard. So, but you're absolutely right. It would be great to put this in terms that people can understand and apply to other problems.
Well, I did want to ask about the noise. That was something in the videos. Now, there is a noise from probably the inductive surface. Is that something that you guys think you'll be able to lick in terms of getting through this?
Well, when you're hovering stuff, acoustics are one of the last things you think of. And there is a noise issue now. We are experiencing some really strange harmonics that we're starting to dial in. We have a basic understanding of them, but we haven't even tried to insulate or cancel them. So there's a lot we can do with the existing technology. But the amazing thing is we're actually changing the configuration, and I think we have a pretty good shot at making a silent version.
Oh, wonderful. Well, we're almost out of time today, so I want to thank you again for joining me. And let me close up here by asking about the future. Where does this project go from here, and what can we expect to see next from ARC's PAX and the Hendo Hover project?
Tim, great question, because it really is all about the future. The underlying technology, magnetic field architecture, can go in so many different directions. We are looking into areas now that we can't talk about, but there are problems that will be solved that will make hovering seem sort of incidental. And we are really excited and committed about really doing good with this technology. And with the help of the crowdfunding community and audiences like yours, I think we'll be able to make a big impact on this planet we call Earth.
Wonderful. Well, thanks again for your time today, and I'd like to direct the audience again to visit hendohover.com, where they can get involved and contribute to this project.